Hi again, guys. We're still working on factoring. Last time we did factoring by the greatest common factor, and we're going to kind of use that in today's lesson. But what we're going to be doing is, first of all, I want to show you how multiplying two binomials can lead to factoring, and we're going to look at it using an area model. So I have this rectangle that's divided into four separate sections. I'm going to say the length of this smaller section there is x, and the length of that one is 4, and over here the width of that square is x, and the width of this rectangle down there, let's let that be 1. I'm going to show you a few different ways that we can multiply and figure out the area of this entire rectangle. The first way is, let's do this section by section. So I want to first talk about the area of this little square here. And remember, the way you find the area is length times width. So x times x would make the area of that yellow square x squared. Then let's find the area of this blue square. One thing you got to remember is, if this is x, then all the way across here, that's x over there. You don't have to write that, but you just got to remember that. So the area of this blue rectangle is 4 times x, or 4x. And then let's find the area of this green rectangle. If this is x, then this down here also is x. 1 times x makes the area of that rectangle x. And then lastly, this rectangle down here is going to be 4 by 1. So 4 times 1 is 4. So that's the area of each colored section. If I want to figure out the area of the entire larger rectangle, all I would do is add up the 4 sections. And that would look like this. The first section is x squared, second section is 4x, third section is x, last section is 4. Combining those middle terms gives you an area of x squared plus 5x plus 4. Okay, so I'm going to rewrite that over here for us to remember that in just a second. Okay, another way that we can figure out the area is like just looking at the entire area of the larger rectangle as a whole. So I'm not going to look at the sections individually. I'm going to look at them as a whole, and I'm going to rewrite my dimensions up here. If I was talking about the length of this larger rectangle, okay, this is where some students have difficult time. I think I hit the wrong button there. There. If the length of this square is x, and then I have 4 more added to it, that's x plus 4, not 4x. The same down here, the width of this larger rectangle is x plus 1. To find the area of the larger rectangle, you would take the length, x plus 4, and multiply it by the width, x plus 1. Remember, multiplying that you distribute. X times x is x squared, x times 1 is x, 4 times x is 4x, 4 times 1 is 4. And you can see if I combine those middle terms again, I have the exact same thing as right there. Okay, and that should make sense. The area, if you figure the area one way, it should be the same area any way you figure it, as long as it is a valid method. Okay, so I want to look at another way. Try to erase the highlighting. I don't want to erase the plus. Okay. What if I want to figure it this way? This section and this section. If I want to do 2 sections instead of 4 sections like I did the first time. Okay, so the area of the blue section is x times x plus 4. And the area of the green section is 1 times x plus 4. And then you would just add the area of the 2 sections together. Now you should be able to see that this x plus 4, that's the length of both of them, and this x plus 1 is the width of both of them together. So again, I could rewrite this as length times width. And I could do it the other way also. So let's look at it the other way. Okay, now if I change my green section to be, or blue section to be that, my green section to be that, see if it works that way. So here we have the length is x, the width is x plus 1, and then the green section is 4 times x plus 1. Again, here's the length, sorry, there's the width that's in both of them, and then the x plus 4 is the length. Okay, and if I were to distribute and then combine all the like terms, I would get the exact same area that I got before. Now, the reason that this helps us is this leads to a method of factoring trinomials called the box method, and it's the opposite of the multiplying here. Okay, before we get into the box method, let's talk about grouping. Okay, when I had this written up here like x, 4, x, 1, and we found the area of each section, and then we came down here and we added them up. If I look at each pair of terms here, and I look at the greatest common factor of each term, or each pair of terms. Let's do that. Let's find the greatest common factor between x squared and 4x. Okay, x squared and 4x can both be divided by x. If I divide x squared by x, I get x. If I divide 4x by x, I get 4. What about the greatest common factor between x and 4? Well, the biggest thing I can divide x and 4 by are 1. If I divide x by 1, I get x. If I divide 4 by 1, I get 4. And if you notice, this is exactly what we had just a few minutes ago. Okay? So, knowing all that, let's do a few examples by grouping. And remember what factoring is, that it is finding what multiplies to give a product. So this is going to look a little bit different, because factoring by grouping is used if you have 4 terms. Okay, 4QR plus 8R plus 3Q plus 6. Okay, first thing I want to tell you is the very first thing you want to do when the directions say factor completely is see if there's a greatest common factor, a number that can divide into the entire polynomial, number or variable. This one does not have one thing that can be divided into everything. But since there are 4 terms, we can see if we can factor them by pairs. And we're going to do that by finding the greatest common factor of each pair. Now 4QR and 8R, I can divide 4 and 8 by 4. And each one of these terms has an R, so I can divide out an R. So let's divide that out. 4QR divided by 4R, all that leaves me is a Q. 8R divided by 4R leaves 2. And if you need that written, this is what I'm doing. This 3Q plus 6, I can divide 3 and 6 both by 3. I can't take a variable out because there's not a variable in both terms. All I can divide out is a 3. If I divide 3Q by 3, that leaves me Q. If I divide 6 by 3, that leaves me 2. Now this should kind of look a little bit like what we did earlier. This would be like the common length, and what was left would be the common width, and we would add them together. So if we were to write this as a product, this would be the length times this, which would be the width. Okay, let's look at another example. Rn plus 5n minus r minus 5, minus r minus 5. Now this one is going to be a little bit different because something's not going to be right here. But as you can see, we can't take a greatest common factor out of the whole thing. So let's look at this in pairs because I have 4 terms. So I'm going to see if I can do this in pairs. So the rn and the 5n, they both have an n in common. So I can divide out an n. That's all I can divide out. If I take an n out, rn divided by n leaves me r. 5n divided by n leaves me 5. Now if you look at this other pair here, before we go on to it, notice back on example number 1, this q plus 2 and q plus 2. I said that's the length of the of both of the sections. The lengths have to be the same for both of the sections. If we do, okay, put that back in. If we take out a 1 here, because r and 5 only are common by 1, if I divide out a 1 here, that would be a positive 1 that I would bring out. Negative r divided by 1 is negative r. Negative 5 divided by 1 is negative 5. My problem here is this length doesn't match this length. However, r and negative r are opposites. 5 and negative 5 are opposites. All I would have to do would be to change both of those signs. And remember, changing a sign is nothing more than multiplying or dividing by negative 1.